Hello everyone, video 1 of module 4. In this module we mainly focus on loading, how to introduce loads, load patterns, load cases and load combinations, and how to apply loads on frame and point and shell elements. But before going through loading section, I would like to complete this model with you to just show you some other commands of drawing elements and creating models. This is the model we used last time for our pile foundation. As you see, I've updated the model. I added all piles and actually replicated the pile caps and just introduced a kind of foundation system here. And I also completed some levels of slabs with 200 slab. I can add sections here to make it better for you. If I come to tools, options, and come to dimension tolerances, here I can change the text size. You can see the text size here is very small, so I can come here and change, for example, minimum graphic to font size to 6, and when I press OK, you can see they are a bit bigger. And you can play with that to figure out what is the best size for you to read. So let's make it 5, probably would be better. Yeah, so you can see the slabs are 200 and just this slab is 250. The reason is I intentionally introduce a column at the middle of this span that I can use it later and show you how to deal with transfer columns in continue when we're doing analysis and design. So we have 3 levels of slab like this, and then level 4, which is Z11, we have a kind of composite slab with 160 slab plus steel beams around. So the arrangement is 180 UB as a secondary beam and then 200 UB parallel with secondary beams, and the main load bearing beams are 250 UB. So I introduced them just to save the time. What we have here at this area is the way the beams are being supported by shell, which may not transfer load properly to the lift wall we have at the middle of the building. So if I come here to YZ direction, currently I'm looking at the wall here, which is similar to lift course, so the concept would be similar. And here you can see that the beams are not exactly matched with the grid line of the mesh. So I have few options here to do. One option is simply rearrange the mesh and match them with the grid line. I can do one of them for you. So if I come here and pick this, then I can select this point. I just need to probably be a little bit closer, so I can match this one with this. So if I zoom back, you can see that this element is edited and now it's matched with the beam. But it's very time consuming procedure, and sometimes the arrangement is not very favorable. You may have quite few walls. So what's the best solution? The other solution is meshing the shell element based on these points. Is not dividing mesh like what we did before, is meshing for analysis. The difference is those are dummy joints, those are not actual joints. So when you add more joints and add more elements, literally you increase the size of your matrices, mass matrix and stiffness matrix. But when you use this kind of auto meshing, it doesn't increase the size of the file, so the file wouldn't be very heavy and analysis wouldn't be actually wouldn't take long. So I can show you what to do. So if you select all those nodes and all shell elements below, you can come here in assign area and go to automatic mesh, automatic area mesh. You can see the options you have here is pretty similar to dividing, but when you use those, it's not physical joint. So if I come here and, for example, select auto mesh based on point, area, edge, and choose this one, point object meshing group at the or on the area edge, and I apply, you see it shows me that edge point, but it doesn't show me any actual division like what we saw before, like what we currently did with vertically here, for example. And for example, if I select those and come here to this option that I used before for you guys, just putting say 2 by 2, and when I press apply, it's just showing this is a mesh of 2 by 2. It literally doesn't actually subdivide the elements. So I press Ctrl Z to back to the previous arrangement. So this is what we can do. The other option we have is adding some beams with strong stiffness to transfer load from these beams to the joint of the shell. So here, if I move back to reach to the wall, and I can come here, so I don't have any beam here currently. I can draw a beam. So the beam should be anything, because this is not of my interest. It could be 150 UB or any other size, just a reasonable size you can choose. I will choose say 250, and I draw it here. And then what I need to do, I need to increase the stiffness of this beam to ensure the loads will be properly transferred to the wall. So I don't want to see too much deflection. Sometimes it could be a very weak beam, but you can increase the stiffness and make it work for you. So if I select this and come to assign and assign frame, here I can change the stiffness without going and change the stiffness of that specific section, because if you change the stiffness of the section, all 250 UBs will be changed. But if I come here and go to this property modifier, here you can increase, for example, a stiffness in 3 directions to 20 and apply. So this will be applied just to the elements you selected, and is sometimes very useful for actually increasing the stiffness of some specific elements. So what else we need to do? We need to select all those joints. We need to select this element as well, and then like what we did for shell, we can do the same for frame element. So coming here to frame, and we have an automatic frame mesh. And here again, what will happen, we are not subdividing the frame to different smaller actually elements. We using this with at intermediate joints and other frames and area edges or solid edges, and then I think just joint here even would be okay, but I'm selecting this one, it doesn't harm anything. So you can see that now this frame is meshed. In analysis I can show you what will happen. So actually what's happening, that the load coming to this point, and from this element it will be transferred to the joints of the shell element, because here the shell element cannot take any load. So if you have any frame, any point here, any load here, this actually point would be unstable. So you either need to mesh the shell, or you need to have such a strong beam to transfer loads. So that is for these elements. I will update this one later on. Just to save the time, I will move on and show you the rest of jobs we need to do for completion of the frame element. So I'm coming here, going to the next level. So this level, if I come to 3D, you can see this level I don't have anything. So what I want to do, I want to draw a portal frame on top. And as portal frame, actually we have some columns at the middle because the span is very long. It's not just a classic definition of portal frame with just 2 columns at the end. So it's a steel frame with a slope to the almost center, and then we will use it later on for applying wind load and other loads. So I'm coming here to XZ elevation. I can see this one properly. So I'm currently at this grid lines, which is grid 8. So I'm coming here and choose this, and I select my section, choose 310 UB, and it's universal beam, but this is the name, so you can use it for column as well. It's up to you. So if I come here, I can draw a frame from here to here, and then another one from here to here. And then I need to draw a beam. So roughly this is a center. It's okay, it doesn't have to be exactly centralized. I'm just drawing some elements for you to show you how to apply load. So using the same section 360 UV, coming from here to here, and then coming to this point. So currently what I'm using is a continuous moment release. So all of them are moment resisting and elements. Now I want to draw some other elements here to reach to those. So how can I do that? If I come here and select my other section, I will adapt those sections later, but say 200 UC for example, I can draw it from here to here, and another one I will draw it from here to here just to show you what can be done. And one here, one here. I'm just intentionally doing this to show you how it can be fixed. So now what we can do, we can select this element with this beam and then come to edit and edit lines and coming to trim and extend. And if I press trim, it's coming to the right location. Likewise here, I'm selecting these and again trim, it's coming here. This frame is a still continuous frame, but it's connected. So it's up to us if we want to divide it or we just want to use automation and connect them together. For this one, what I can do, I can select these and these and then press extend, and that will do the same. So here again, select these and these, and I can press extend, and that will. So this is basically the frame I want to have. Now how can I replicate these? Simply I can choose this one, then I can come to one elevation to make it more visible for me. So if I come to YZ elevation, I can see this frame here. Now I want to move it to other grids. So what I can do, I can use replicate and then pick 2 points and say from this point to this point. I don't want to delete it, apply. And I just use previous selection and doing the same for the rest. Okay guys, just to save the time, I've done this one and then I started recording to ensure that video wouldn't be very long because it's just repeating the same command. Now I'm coming to 3D and just deactivating grid line to make it more clear. I don't want to see levels below because it's a bit actually busy now. So what I can do, I can come to view and go to set limit and say I want to see from Z11 above. So I put Z11 above and I apply. So now I just can see this level. Even I can come to say Z12 to not to show that below level slab, so I can just see my beams, which is okay with what I want to do. So now I want to draw the struts. So I'm coming here, I'm choosing a hollow section or CHS for a strut. I'm using pinned, and then I'm just drawing struts here, and then I can replicate them very quickly by selecting those. So this is one type selection, and then again I'm coming to replicate and do the same. So I can pick 2 points. This is very useful option because it's automatically calculating all difference in X and Y and Z, and you can easily apply this. So it's like that. So just again previous selection, pick 2 points, and this time we're going up, apply, and we will do the same to complete this. Okay, roof struts are completed. Now I want to add roof braces. So I'm using 90 by 90 by 10 EA pin connection. The reason I'm choosing this heavy section is because we don't have nonlinear analysis. We cannot use tension only member. We can choose lighter sections, but they should be tension only. But because we don't have nonlinear analysis, we cannot use tension only member. So I'm choosing these and drawing my roof braces, and then I will show you what we need to do to make it work, because even 19 by 90 by 10 could be weak for this span, especially because of the weight. We have a little bit bending as well. So I will generate the braces all around, and then we can continue from there. Okay, roof braces are completed. Just bear in mind that roof braces don't have to be right all around the building. It really backs to the location of the vertical braces. So if, for example, vertical braces are in this bay, you need to move these braces here. So let's move on, and I will just change this view limit to be able to see the columns. Okay, now it's better if I come to elevation to draw the vertical braces. So it's up to me how I want to define the lateral resisting system. So if the lateral resisting system in this way is moment resisting, we don't need any brace in these two ends, but for allowing the building we need 2 braces, and because the roof braces are here, I will introduce bracings at the end. So currently I'm on grid F, so I need to move forward to reach to the latest grid, which is these 2 grids. So I am currently on this grid, which is grid A. So I draw my section. I'm choosing 125 by 125 by 10 EA. See how we go in our design later. So I will draw elements here. So I can simply switch to the other grid and draw, or I can replicate it. I generally replicate is easier, so I choose those 2 and use replicate, pick 2 points from this end to this end and apply. So I have vertical braces at both sides. So this is generally the steel structure we have on top of our building. Now it's time to define and apply loads.